Hey everyone, I just wanted to use this video to show you how to do quiz 3. So let's get started. So let me go over to the quiz. Here's the quiz itself. We're basically going to do some stuff with this data. These are ostensibly test scores. I believe I made these up. I don't think these are real, but we'll pretend they're real. So we're going to do all of this stuff with them. Make a stem and leaf plot, find 5-number summary, IQR, box plot. Those all go together, of course. Describe how the data looks, find the mode of the data, and then we'll talk about why we don't care about that, the mean or average, standard deviation, and then determine if there are any outliers. So what all I've done so far is type this into sheets, right? I've got the data here. I've checked to see that it's working correctly. And so I'm going to find all those things that we said, right? So we can find, I'm actually going to show you how to find the quartiles and make the box plot and do the 7-leaf. I'm going to do all that by hand, I think. Just because it's helpful to be able to do it by hand, and then we'll go ahead and have sheets do it as well. So, all right. So if I want to find or if I want to make a stem and leaf, let's start with the stem and leaf. I'll go ahead and make a whiteboard here. So what we're going to do for stem and leaf is pretty simple. I'm just going to do this. My stems were, they started at 18 was the low one and 101 was the high one. I guess I'll make this a little bit bigger. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we're just going to put all the numbers in the appropriate rows. So let's see here. The first one was 18, 26, 34, 42. Oops, where'd this go? 18, 26, 34, 42. So we've got 18, 26, 34, 42. 55, 57, 63, 70. 55, 57, 63, 70. I think there's a bunch of 7s, right? So we've got, in the 7s, we've got 2, 2, 3, 4, 5, 5, 6, 7. 2, 2, 3, 4, 5, 5, 6, 7. Okay. 2, 2, 3, 4, 5, 5, 6, 7. Yeah, I definitely made this data up. There's never that many 70s. And in the 80s, we've got 0, 2, 2, 2, 4, 5, 7, 8. 0, 2, 2, 2, 4, 5, 7, 8. Okay. 0, 2, 2, 2, 4, 5, 7, 8. Yes, it's way too spread out to be an actual test. 90s, we got, and then above that, we've got 93, 97, 101, and that's it. All right, so 93, 97, 101. 3, 97, 101. All right, so we can see what the data looks like here. Just from a descriptive sense, which is one of the questions coming up, it's got one peak, right? So again, this is a stem and leaf. We're going to take it and turn it on its side, and then it's a histogram, basically. And so we can see that it is very unimodal. There's a peak right in here somewhere in the between 70 and 80, and the data is spread. Technically this is sort of a peak, but not really. There's only 2 numbers in the 50s. Yeah, so it's just got one peak. It is definitely skewed to the left, right? So picture tipping it this way, left is low, right? So it's skewed to the low end. And we'll see if there's any outliers. I'm going to guess, now I don't know this for sure, but I'm going to guess that a couple of these are outliers. I haven't checked it yet. It's been a while since I wrote this quiz, so I don't actually remember if there are any. But I'm guessing some of these guys are outliers. But we'll see. We'll see in a little bit. Okay, so there's my stem and leaf. This is a nice compact way of displaying all this data, right? Notice how it does a good job of showing you what the data looks like without just being a list of numbers, right? I mean, it is technically a list of numbers, but it's arranged in such a way that you can actually see where the clusters are. That's the idea. So let's see here. Let's go back to the quiz. So that's my stem and leaf. We're going to find the 5-number summary. I'll go ahead and find it right here. If I do that, does that delete the? Yeah, I think it does. Deletes the whiteboard, I believe. We'll see. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29. So we have 29. That means that we're going to look in the 29 plus 1 over 2, which is 15th position for the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my God, I lost count. 3, 6, 9, 12, 15. All right, so 15th position looks like 76. So let's just make a quick check. There's 14 above that. 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, there are. Great. So that means that there's 14 above and below this. So I'm going to look in the 7.5 position, which is say between 7 and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So there we go. There's Q1. 1, 2, 3, 4, 5, 6, 7, 8. So there's Q3. All right, so we got Q1, which is average of 63 and 70 is 166.5. Or excuse me, sorry, that's 133 over 2, which is 65 plus 1.5, which is 66.5. Yeah, 66.5. There we go. And halfway between 82 and 84. Don't need to do much math on that one. Q3 equals 83. Okay. So if we want to find the IQR is going to be the difference between those. So this guy is 83 minus 66.5. So just a little trick for you for subtracting. Like this would be a little bit of a mess to do in your head, unless you think of it this way. So from 66.5 up to 70 is 3.5. From 70 to 80 is 10, so 13.5. And then from 80 to 83 is another 3, so we got 16.5. 16.5. And then we're going to make a box plot of that. And I'm going to go ahead and do that by hand. I might as well do it right here, and we'll wipe it all off afterwards. Is that what I want to do? That's not what I want to do. No, that's fine. I'll do it here to show you what it looks like, right? So if we make a box plot, we have to find the minimum and the maximum, which of course are 18 and 101, right? So there's your min and then your max. So those numbers that I've circled and the quartiles are the 5-number summary. And again, this will all be on a nice document so you can see what it looks like in a little bit. Make the box plot. What I'm going to do is, as always, I'm going to draw my number line. And then I need to go from, let's say 10 to 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 100, 20, 30, let's do this, 30, 50. Well, that's not going to work, is it? 70, whatever, that's fine, 90. Okay. I guess 101 is going to be a little bit above that, but that's fine. It's right next to it. So we're going to put these things on here. So 18 goes like here. That's more like 15. We're going to do that. Do a better job. 18. 26 is about here. 34. No. What am I doing? That doesn't go on there. 66.5. That's the next thing. 66.5 is over here. 76, which is like here, I guess. Yeah. 83, which is over there. And then 101, which is here. All right, and then we just draw our little box and our arms, also called the whiskers, which seems like a weird name to me. And there's my box plot. It's pretty straightforward. Yeah, remember that it's just the 5-number summary in graphic form. That's all it is. If I'm describing the shape of this, it looks like it's skewed left. You can tell because remember that there's 25% of the data in each of these groups. So in this arm, in the right half of the box, left half of the box, and also this very long arm here, that just means it's very sparse in here. So what this means is most of the data is here. Like this is the middle 50% of the data. There's a little bit to the right, and to the left, there's the same amount, but it's spread way out. So if there are any outliers, they're all going to be over here. The things that are far away are going to be to the left. So I would describe this as unimodal and skewed to the left. It's not symmetrical, right? There's more, or the left data is much more spread out than the right data. Find the mode, you can actually just look and see that the mode's 82. There's nothing else with 3, and then there's 3 82. So 82 is the mode. The reason I don't care about the mode of this data is the data is quantitative. And again, let's say that one of those people got an 82 instead got an 81, or let's say 2 of them, one got an 81 and one got an 83, right? That changes the data essentially not at all, like in no meaningful way. But it changes what the mode is to 72 or something else that there's 2 of, 75, right? But that's not doing a good job of telling me what the typical score is if changing it in some negligible way completely changes what the typical score is. So we don't care about that. It's quantitative data. We use means for those, sometimes a few other things. But to describe our typical score, we're going to use the mean, or I guess the median in this case. All right, and then we're going to find the mean and standard deviation. We're going to do that in sheets. I'm not going to do that by hand, although you totally could, but I'm not going to bother. So let's. I'm in text mode. There we go. Let's do this. Let's go over here. I guess I'm going to clear all the drawings. There we go. That's fine. So if I want the average, remember that we can do this equals average of, and then you can just grab these. Okay, there we go. Average of those things, close parentheses. No. What on earth? I don't know what it's doing there. Average is 71.6. Let's actually take this and put it over here and delete that, and so that I can whatever average. What is this? That's A22, A30. Standard deviation. What on earth? Why is it italicizing? What? Oh, I know why. Yeah, don't worry about it. It's still doing it, even though I said not to. Okay. Widen that a little bit. All right. Standard deviation equals STDEV for standard deviation. It was A2 to A30. There we go. And then we get a standard deviation of 20, 19.98, which is actually very high. Yeah, so I know you guys don't know what usual standard deviations look like for test scores, but that's pretty high. You usually see them between 12 and 15, something like that. And ideally, I would like it to be a little bit lower, maybe around 10, but it's pretty much impossible to achieve a 10. At least for me, the way I write my tests, I'm sure some people can do it. I usually find that if the standard deviation is really high, that means that I have made the test too consistently difficult. Now I don't want to say consistently difficult, but I made the difficulty on the problems all very similar, which I know sounds really strange because higher standard deviation means more spread out, but I don't want to go into too much detail here, but basically what ends up happening is if you make things all the same difficulty, then anyone who can answer a question of that difficulty gets them all right, and anyone who can't gets them all wrong, and you get like this bifurcation, which we didn't really get here. So maybe that's not what's going on here. Anyway, I made up this data, so it doesn't matter. But standard deviation is 20, which is a little bit high. It tells you how spread out the data is, and if you're looking for the technical definition, it is the average distance to the mean for all the data points. Let's see here. Mode, mean, standard deviation, S or sigma for the standard deviation. The answer to this is not clear cut, actually. It depends on what you're thinking of as the population. If you're thinking of all of my stats students as the population, rather than just this class, then we should use S for this. If we're thinking of just this particular class, then you should use sigma. S for statistic and sigma for the parameter. So it really depends on what you're trying to do. when I wrote this, I was thinking of using S. And the reason I'm thinking about it as S is I'm thinking about like the standard deviation. I'm thinking about this as a sample of some of my stats students as opposed to all of the people in this class, right? Depends on what I'm trying to generalize to. And I usually want to generalize to like all of my students rather than just one class's worth of them. So I'm thinking of it as S, but if you want to make an argument that this should be sigma, you can. Like there's a reasonable argument to be made there. And then we're going to determine if there are any outliers. So the way we find outliers is by doing the 1.5 times IQR method. So remember that we had, where am I at here? I want to annotate this, pardon me. We had our IQR. We had IQR was 16.5. And so 1.5 times 16.5. Oh, can I do that? So the way I'm going to do this, and I hope you guys are okay with this. I'm going to do 16 times 1.5 plus 0.5 times 1.5 because this is 16 plus. So I'm essentially distributing this or undistributing because those are each individually easier to do. So 1.5 times 16 is, gosh, what is that? 24. And 1.5 times 0.5 is 0.75. So this guy would be 24.75. And then we had between 7th and 8th, 2, 3, 4, 5, 6, 7, 8. So we had this. This was 66.5. That was Q1. So anything past 24.75 below that would be an outlier. So 24.5 below that would be 42. It would be 42. So I need to go there 0.25 down. So anything under 41.75. So my inner fence, my lower inner fence is right here. And so I have all these 18, 26, and 34 are all outliers on the bottom end. On the top end, we had Q3 was 83. And so anything that's more than 24.75 above that, which would be 107.75, which there isn't anything above that. So there are no outliers on the top end. So there are, that's what the outliers are. They're these guys. All these three are outliers and there aren't any other ones. And then how do we handle them? So that's actually a really interesting question. And this is a practical question that I have all the time. Because whenever somebody asks me, like, what was the average on the test? Well, I don't know exactly what to include and what not to include, right? So let's say that this person who got an 18 on the test was not really, like, they didn't attend any classes and they didn't turn in any homework and they really weren't making much of an attempt to pass the class. Do I include them in the average on the test? Or do I include them in the test average that I'm reporting to my students? And my answer to that question is no, I don't. And the reason that I don't is when somebody asks what was the average on the test, what they're really asking is how did I do relative to a typical student, or how did a typical student do, and then they look at their score and compare it, right? And so when they say when I'm saying a typical student, they don't really mean how did I do compared to everyone in the class, including the people who weren't trying. I only want to compare somebody who is trying to somebody else who is also trying. Right. And so these are all, like, let's say, for instance, this person who got an 18 wasn't really making any attempt, but this person who got a 26 was. They did their best. It just went really badly, right? For whatever reason, they didn't grasp the material, just kind of a disaster. Well, I would include them, right? I would include them in the average, even though they're an outlier. And I would exclude this person who got an 18 if they weren't really trying, if they're an outlier. Right? So if somebody's not making any significant effort, I will generally exclude them from the average. Not because they were an outlier. Like, I'll include outliers if they are the same type of data, right? If it's a student who's trying, I will put them in the average, and if they're not, I won't. You generally find them in the outliers. If I get somebody who's not an outlier, so for instance, like, let's say this person got a 63. Let's say they weren't trying either, but they just happen to know some of the stuff on test, or maybe they're really good test takers or whatever, I would still include them. I only really make this determination for people who are outliers to throw them out because it's hard for me to tell how hard somebody who got a 63 is trying. it's relatively easy to tell how hard somebody who got an 18 is trying, right? Like you'll notice that they don't have any homeworks in, and they're missing half the classes. Obviously they're not really making an effort. So would I do the same thing if I was reporting the average test score for an independent study of stat students? No, I wouldn't. I would give them all the data. Because if they're doing an independent study of stat students, they probably want to include even the people who are not making an effort. But if I want to tell my students what the average on the test was, I only want to include the people who are actually making an effort to do well in the test. So if there are outliers, so I guess the upshot of this is there are outliers. 18, 26, 34, those don't meet, or those are outliers by the 1.5 times IQR method. Depending on the individual students and how they were behaving in the class, not behaving, that sounds like they're, naughty or whatever. Depending on how much effort they were putting into the class, I might or might not include them in the average. And I think that's all I want to say about this. So I'm going to go ahead and stop the video now, and I will see you in the next one.